Hello, good morning, and welcome to Future-Proof Mobile Cross-Platform Apps with Flutter. My name is Christian Wenz, and I'm pretty excited that all of you are here this morning, and especially those who are watching it live right now and are in one of those countries where there's a national holiday today. So you are literally spending your spare time with me, and I think a pretty interesting technology and a pretty interesting topic. So for the next 45 to 55 minutes, I would like to give you a friendly introduction to Flutter to show you how to get started, how things kind of work, some things that maybe don't work that well yet, and just to put you on the right track to creating your own apps with Flutter. Now, I've been doing mobile apps for quite a long time now, and there are always, different kinds of approaches how you can do that, and I tried most of them. And there have been phases where I preferred one approach over the other, and these preferences of mine, they changed as the technologies available to me changed. Basically, if you do mobile app development, you have more or less three different approaches. The first one is to do native development, meaning you're using the operating system, the mobile operating systems, vendors' preferred approach and technology, and you create a native app, an app that is using the language of choice and, of course, the platform SDK, and then only runs natively on that very platform. So it's tailored to exactly the target system you're using. So here I have put the sexier options you have on the two major platforms. So Swift on iOS, Kotlin for Android, but of course you could also use Objective-C and Java, but of course having maybe a more recent program language is maybe a good approach these days. And the other approach is to create what some call a hybrid app. A hybrid in a sense of that you make a web app and a website and a mobile app at the same time. So basically, you're using everyone's favorite language these days, JavaScript, and you use HTML and CSS for the UI. And this all works as a mobile app as well, because mobile browsers are on par feature-wise and to some degree also performance-wise with the desktop counterparts. Meaning you create an app, use all of the greatest browser features, and then basically what you get in the end is a native app, which consists of a web browser control, a widget at 100% width, 100% height. Then this web browser control runs your web app, but it still then runs on an app that can be put in the App Store or the market. And of course, native is the most direct way to do things, but especially if you target several platforms, the most expensive one. Hybrid is the easiest one, but maybe from a performance and also to some degree from a feature point of view, not always the best option. And the third approach, which can be used to some extent these days, is a cross-platform approach. So for instance, one that Xamarin does, especially with Xamarin Forms, which gives you cross-platform UI approach, or React Native. And Flutter falls into that third category. So you use not a language as dictated by the mobile operating system, but you use a language of, your choosing, or in that case, the framework's choosing. And you have one base, and you still get an iOS app and an Android app and other apps like macOS apps or Windows apps from that same code base, because it's then compiled into the language of the mobile platform you are using. And actually, I've encountered Flutter rather early on. Because, well, as it says on the Flutter homepage, Flutter is Google's UI toolkit for building beautiful, natively compiled, that's what I mentioned, applications for mobile, web, and desktop. Well, most of the time, mobile is the key use case here, but the other options work as well, from a single code base. Pretty interesting. And it kind of the interest that I got early on in Flutter stemmed from several of my customers who were doing their long-term mobile app strategy planning. And they were a bit nervous because of the upcoming Google Fuchsia operating system, where there's like more rumors than code at the moment. And in that operating system, they're not sure whether they're the hybrid apps, and they had a lot of hybrid apps. At least those customers would still work, and so they thought, okay, if Google comes up with their own framework, maybe this is the one way to go in the future, and if it works cross-platform, even better. So I started looking early on, and there were quite a few things I liked. So that's what sparked the idea for this talk as well. So I'd like to share my experience with you. The first time the project was actually mentioned was in 2015 at the Dart Developer Summit. Back then it was still called Project Sky, and it took a while, but after renamed to Flutter, version 1.0 did come out in 2018. So it's at least a 1.0 version, which is always a good sign, I guess. And as of today, we have Flutter version 1.17.3. Actually, I'll be showing you Flutter 1.18, the beta version of the next release of Flutter, because I would like to show you one very specific feature, and that one is only available with 1.18. But we'll come to that a little bit later. So that's the background of the project and the short history of it. And if the go-to places for Flutter are, of course, the Flutter homepage, flutter.dev. And if you're interested in the source code, then you will, of course, go to GitHub, where the Flutter project has its home. And the first thing you will probably notice when you go to that GitHub page is not that it has, I think, 98,000 stars, which is very, very good, right? No, it's probably the more than 5,000 issues. Actually, I've never seen this plus sign here before, and I mean, Xamarin Forms has, I think, half of that. But that's not a red flag, at least in my book. Many of those issues are just, people having the same issues all over again, or people using the issue tracker as a kind of a support channel for the applications. And so, well, see it as a sign of good traction. Also, I have to say that I don't say that for many open source projects, but they are the team there is shockingly friendly when it comes to discussing in the issue tracker, and also when it comes to handling pull requests. For instance, I've also landed pull requests in Flutter, and they were really more than friendly and welcoming, which not all projects do. And actually, I ran into an issue just a while ago, and there was an actual issue in GitHub for that, and I was reading through that issue, and eventually the person reporting that issue just didn't reply questions for more details, as it happens a lot. But instead of just saying, okay, goodbye, we are just closing this, really the team wrote a really sincere apology that they now have to close this because there's no information for them to reproduce the issue. But anytime if the reporter or someone else would chime in with more details, they'd be more than happy to continue working on that. So that was really a shocking experience for me. In a good way, so it's a very friendly atmosphere, which in my book is also a good indicator for the quality of a project. Now, when you work with Flutter, there are a few things which you may need to know because of technology choices the Flutter team made. First of all, Google's language Dart. So Flutter is using Dart as their language. I mean, I still remember when Dart first came up, and then the plan was to kind of obsolete JavaScript by including a Dart VM in Google Chrome, which never materialized, luckily, in my book. But still, very interesting, also very young language. At the TOB index, it's growing quite a bit, but I mean, still, it's I think number 25 on that list, 4 places ahead of COBOL. So that's still nothing in comparison to let's say Visual Basic, or on a more serious note, C or C++ or C#. But still, so growing interest. In Dart. Dart is the language of choice. I won't give you an introduction to Dart, but I think the syntax looks similar to other languages, so I think we'll be just very, very fine. And the second thing that is a deliberate choice, more or less, has to do with the design concept of applications created with Flutter, and the recommended approach, so to speak, is to use material design. Which is this design language also supported by Google. And this is also what is used most of the time in the documentation, and most apps are using material design. Now, there's also something called Cupertino design, which, as you might guess from the name, has to do with iOS. So that's basically the iOS design language. Flutter also supports Cupertino design. So there are, let's just say, components. I'll use another term for that later, but let's just say components that just looks like on iOS, which of course means on iOS, it's just the components that the OS provides, but on Android, they are just emulated, right? So you can have a uniform design, but you can also have a design that is tailored to the target operating system. So both choices exist, but you'll see material and Cupertino later on today in this talk. Now, when you'd like to set up your development system to use Flutter, there are a few things which you need to set up and install. And my recommendation is this. I mean, you know, when I get a new gadget or new device, I'm too stubborn to actually read the instructions, because, you know, I can do this. I work in the industry. I plug it in and it's working. I know, but still, please do read the instructions, because there's some caveats that might not be obvious at first. For instance, for Android setup, at least in the current version, you need to install an old obsoleted versions of some tools, because that's what Flutter is currently expecting, right? And if you just do a vanilla install, then you miss these things, and you get a very weird error message, which doesn't really tell you what's up. So do follow the instructions, install Flutter, and then install an IDE. I mean, the choice that's recommended in the documentation, and which I also personally recommend, is to use Android Studio, because it also sets up the Android SDK and is a fine IDE. However, if you're a Visual Studio Code user, then you can also use Flutter with almost the same functionality as well. And I intend to show you both today briefly. And third, of course, for iOS, you need the software, which is then used on iOS to, well, test the app. So you need the emulator, and then you also need the platform SDK, and that's Mac only. And of course, that's Xcode 11. I'm presenting today on a Windows machine, so we'll have a look at the Android version of things. If I presented on a Mac, then I could have easily shown both the iOS emulator and also an Android emulator, but generally it doesn't really matter where you develop things on, but once you approach testing a bit more, and then of course you need all target systems available for you. All right, now after you've installed Flutter, the first thing you'll probably try out is the Flutter CLI. The Flutter CLI can be used to do a lot of things, including creating new projects, starting compilation, etc. but the first thing you will probably encounter is Flutter Doctor. So Flutter Doctor gives you detailed information about the Flutter installation on your system, and also tells you if something is missing, if you need to install a target device to test Flutter on, etc. So that's actually pretty interesting, and I will see that in a bit as well. And the next thing is Flutter Upgrade. What Flutter Upgrade does is it updates the current Flutter installation on your system. So it has a built-in update mechanism, which I think is pretty convenient. But without any further ado, how about we start working with that thing? So I have Android Studio here, the version that came out like 1 or 2 weeks ago. And if you go here to configure, I hope you can see that on the small screen, but what we have there is a section called plugins. And in that plugin section, you can install several plugins into Android Studio. Now, I did that beforehand because it always tends to load quite a bit. So I did install, among other things, the Flutter plugin and the Dart plugin. And after doing that, I have here a Start a New Flutter Project button, and then I get this wizard where I can create a Flutter application or other Flutter things. And then I have to set up a project. So the general consensus for Flutter apps and the naming scheme is use lowercase letters and use the underscore as a separator. So let's do hello Flutter. Then you have to provide the path where you installed the Flutter SDK. Unfortunately, that box is never pre-filled for me, so I have to remember where that SDK is. And then after some more setting up, the Flutter project is created in Android Studio. And we'll see another option to create a new Flutter project in quite a bit. Now, this is Android Studio, and I think the most interesting aspect here on top is the bar where I see all of the devices available for usage. And if you have a device connected to your machine, it would show up here. If on iOS the emulator was running, it would show up here. And well, actually, I do have an emulator. So I have a phone here, and then basically I can compile the application, and then it runs. And we'll have a closer look at what exactly is happening in a bit. Now, if you know some of those frameworks or technologies where when you see a Hello World demo, you always see the same thing. So the same demo. So let's just say arbitrary example, a Blazor demo. You always see kind of this one increase counter thing. Sorry, I have to disappoint you. The same thing might happen here when we work with Flutter as well. So very similar approaches, but there are some really nice effects which are used here all over the place. Now, what I intend to do is I'd like to show you how to set up simple Hello World, just to show you how Flutter is generally working and what the approach is, both from a code perspective and also from a UI perspective. Talking about UI perspective, there's no visual designer, so we'll be working with code only exclusively and set things up there. But the approach and the syntax, I think, is actually quite intuitive. All right. Okay. So how is Android Studio doing? Insufficient storage, which is a bug that happens from time to time. And the only thing that works there for some reason is that you have to restart the phone, which is a bit weird, but I mean, it's still confusing working with those devices as well. Now, while this is trying to restart, and actually let me force them to restart as well, I'll show you a second approach, which can be done, and I'll show you that before I relaunch the IDE again. It's Visual Studio Code. Now, in Visual Studio Code, if you go to the extension menu, you can install several extensions into Visual Studio Code. And I also installed two here, Flutter and Dart, so kind of same approach as with Android Studio. And as the effect of that, if I hit Control, Shift, and P, I can run a few things, including Flutter Doctor. So they are now baked into Visual Studio Code. And what Flutter Doctor does, as I already mentioned, is it analyzes your system, whether everything is set up correctly. Now, for some reason, it doesn't show it me on the system. So let's use the alternative approach and do it in a console. All right, so it tells me basically, or consider, all right, it tells me the version of Flutter we have been using, whether the, in that case, Android SDK is properly set up, if there are any devices connected. In my case here, yes, there are two devices which are connected, and kind of which editors are available where the Flutter plugin has been installed and registered, right? So this all should work pretty smoothly. Now, the next thing I like to show you also in Visual Studio Code is I can also set up a new project here, and I could call this Hello Flutter VS Code. And this sets up a new project in a folder of my choosing, and then I have this assistant, this wizard that is creating the project for me, sets it up with a sample application, and then we can run it. Now, the first thing you'll see is these red squiggly lines, like something was wrong, but it is just loading the libraries used here. So now the squiggly lines are gone without me doing anything. Now, when I run this, I just open the configuration because I mentioned to you that I'm using the pre-release version 1.18 of Flutter, because what this does is it also offers us a way to run Flutter in a web browser, which is kind of nice for debugging, but of course for real debugging and testing, only the real hardware is sensible to use. But after I set this up, I can hit F5, and then the sample app here is compiled and sent to Chrome browser on my system. So after a short while, the Chrome browser will open up and will show the sample app. All right. Actually, while this is taking some time here, I'll restart my Android emulator as well and wait for Chrome to launch. Eventually. All right. I did pray to the demo gods today quite a bit. Okay, there we are. So browser opens up. It will stay blank for a while, but then we'll see the app being loaded and displayed. And the app shows you, hey, a button and a text. You have pushed the button this many times, and well, when I click that button, the counter increases. That's pretty awesome, isn't it? Well, I mean, it's a nice way to explain the basic principles. Also, we can use something here which is called the Dart Dev Tools. And if we open them, another Chrome browser window opens. And this Chrome browser window, the Dart Dev Tools, have a Flutter inspector here, and it shows me all of the elements of my page. So for instance, here's a text element, and it's hard to see here. Let me zoom in a little bit. You have pushed the button this many times. That's probably that text element we just saw in the browser. And here 15, because that was the number that was just shown there. So it's really nice to debug locally. But yeah, it's just in the browser, which might not necessarily be a long-term solution, unless, of course, you are targeting the browser as well. All right. That being said and done, let's have a look at some of the background, how everything works. You see here the Hello World example I intend to show you, and I show you the relevant portion of the code that is required to set this up. Everything, well, almost everything in Flutter is a widget, and we'll talk about widgets in a bit. But basically, we have something called a stateless widget. That's a class we can extend to create our app. And there we have to override the build method. And the build method basically tells Flutter, okay, the UI consists of these components or widgets. Now, how does this look here? First of all, I say, hey, I'd like to have a material app. Remember, that's what I showed you on a previous slide. So that's the design language, so to speak, we'd like to use. You could also say Cupertino app. Then the iOS approach would be used. There are differences between Material and Cupertino, not just in terms of how certain controls look, but also how over-scrolling works, etc. Right? So I do Material app, so this kind of gives me the app. Then I give the app a title. It says Flutter demo here, but you don't see Flutter demo on the right. Well, that's basically the title of the app if you scroll through the opened apps on your device. So that's where this text will appear. And this material app has a home, basically the UI element, which will be shown automatically. And that's a scaffold. Scaffold, as you know from scaffolding, basically gives you a uniform scaffold. A scaffold gives you a scaffold. Well, a uniform look for your app with several things already in place. For instance, that here, while in debug mode, you get this debug banner top right. Now, in this scaffold, you can set up an app bar, which I'm doing here. So this is the app bar. The app bar has a title, Hello World, and well, I could also give it a color, etc. And apart from that, we also have the body of the app that's underneath the app bar. And here that body is something that is centered. That's why I have the center here. And the center element centers its contents, right? So that's the intuitive approach. The center element has a child, and the child is a text element, and text is hello world. Right? That's how the code on the left turns into what you see on the right. So that's I think pretty easy to understand and to see. And we'll have a look at the app that is created by the installation or by the wizard here as well. But okay, we still get insufficient storage. Let me actually reset that again. I've tried it so often and it always worked. So really weird. Okay, let's try this once again. Restart once again. And then go ahead with that. But the demo app has one additional aspect, but we'll come to that once the emulator is back up and running. And actually, for the sake of ruling out any other issues, I'll restart Android Studio again. All right. And let's see if that works better. If not, I can still share the sample apps I've prepared and show you the remainder of the content. Talking about the remainder of the content, I was talking about widgets before. So while we have seen a few of those widgets, but there is a whole catalog of widgets on the Flutter website, which you can have a look at. And there are several categories. And however, there are two main categories. One is so-called stateless widgets, and others are stateful widgets. So actually, since this has reappeared, and there are devices. The device list is currently filled. Actually, let me try starting this one final time. Otherwise, we'll just use code. So stateless widgets and stateful widgets. Stateless widgets are widgets that do not have a state, meaning they don't store any pieces of information. And we've seen a few of those widgets. So for instance, the material app widget we've seen, or the center widget is something without a state. You set a text there, and basically that's it. However, what if something changes? And in that case, we have something called a stateful widget. So a stateful widget is a widget that has a state. Okay, that doesn't make that much sense, but you'll see what exactly is happening when we take a deeper look at this. So stateful widgets, they derive from a class called Stateful Widgets. So the classes, they are immutable, but the state, however, is mutable. And what you then do in those widget classes, and we'll have a look at that in code in a bit, is that you override the createState method. Essentially, you assign a state to that widget, and the state is a class. The class derives from state of the name or the class of your widget. And then you have a couple of helper methods which you can then implement. So init state, so you set up the state once the widget is created. You can set the state, meaning you can change something in the widget. And I'll show you that in the example, actually. Okay, still insufficient storage. That's interesting. Let me run it in Chrome then. It's the same app you've seen before, but I'll show you the code that is created by the opening wizard. So first of all, we have a main file, main.dart, and in the main method we call run app. It's a helper method, and it requires, well, the actual app. The actual app is a stateless widget and needs to implement the build method. And in the build method, it needs to return, well, essentially the app. The app is just opening up. And we are using a material app with a title, Flutter Demo. You've seen that before. Then you can set a theme, so we're using a blue color and some other options. And the home of that app is, and you saw on the slides, I'm using just center, but here we're using something more complex. So we created a new class, my homepage, and that one is the content of the material app. Now, my homepage extends stateful widget. So this is a stateful widget because my homepage needs to keep some information. Remember, this is the app. It's still working. But here we maintain state. We maintain the number of clicks the user has already done on a button in that application. So it's stateful now. So we have to maintain this piece of information. So how do we do that? Well, we call createState in our class, which gives us or creates the state we are using in our class. Now, the method which we call extends state of my homepage. My homepage is the class name we chose for our stateful widget. And within that class, we have a property counter, prefixed with an underscore so that it's private. And that is basically our state, right? So when we want to increment our counter, we can't just increment our counter, we have to do set state, and then we have an anonymous function, and then we increment our counter, right? By a set state, we tell the Flutter system that we have changed the state of our stateful widget, which of course means that Flutter needs to re-render that. So when do we call this increment counter method? Well, in our stateful widget, we still have the build method. And the build method, once again, returns scaffold with an app bar and a body. The body is centered. However, this time in the body, we don't have just the text element as the child. We have a column. It means we have several things we put over or under each other. And within the this column method or constructor, we just use a comma-separated list of what we want, but you'll see it in a bit. So it's centered, and it has children, and all the children are widgets, and we have an array of widgets. First of all, we have a text. You have pushed the button this many times. And then we have another text, and this text is using the underscore counter variable. So that's a syntax similar to one PHP is using, where I can use variable names within a string, right? So we're using the counter in that text here, and the counter is increased by 1, and this set state is called for that, when some other things happen. Well, what are these other things? We have a floating action button. A floating action button is part of that scaffolding template, and it's always here on in the lower right corner, because that's one of these elements of the design language, that you have the button down there. And when we press on that button, then we increment the counter. We call the _increment counter method. Thus, we update the state of the stateful widget. And since the state is updated, meaning the counter, Flutter knows that everything needs to be re-rendered. And that's why we click here, the number here is updated. And so what happens if I change some text here? I save this. And you see that the updated text appears here as well. Let me zoom in a little bit, right? So I was saving, and then I was going back to the browser, and it has already been updated. And this is called hot reloading. Now, truth to be told, since I have to show this to you in the browser now, apologies for that, that doesn't look that much of a miracle, but it also works in the emulator. So if you hot reloading is activated by default, and if you go into the emulator and you change a text in the code and save it, and you switch back to the emulator, the text change will be already there. And you see that the text now has been updated. In that specific case, the counter was reset to 0. In the emulator, the counter would have maintained its state, because, well, they were just reloading with the new text, but the counter would still have its old value. There's also a button here which explicitly triggers the hot reload, and you can not only do a hot reload of a widget, you can also do a hot reload of the application. In that specific case, you reset the counter to 0 there as well. All right. So that's basically how these things happen. I've prepared a couple of sample apps. I intended to do some of them live, but I think I just show you the code now because of the not always cooperating emulator here. And what I did here is, oh, that's the wrong project. I'd like to show you here. A very simple project is a project that implements or shows you the strength of a password, because that just sums up everything I've shown you so far. And I start with main dart again, and actually, how about we try to compile this once more, just for good measure. So this app shows a password field, and while you type in something into the password field, you get an info. This is a strong password, or this is not a strong password. So this is the most simple approach I came up with. Oh, actually, this one works for some reason. So I can show you actually the application in the emulator. Weird thing. Okay, so I type in a password, and I have a very, very simple approach to determine whether the password is secure or not. The longer, the better. So I think starting with 8 characters, I just say it's safe, even if it's just password, which is also 8 characters. So you see the chosen password is not strong. That's the small text here. And I start typing 1, 2, 3, 4, 5, 6, 7. Still not strong. I hit 8. Now the chosen password is strong. Simple example. But if you look at the code, you see immediately how a stateful widget works, and when we can also work with a stateless widget. So let's have a look at the code. Main method calls run app of my app. My app extends stateless widget. And in the build method, I return a material app, and the home of it, the content of it, is the password strength field. The password strength field is a stateful widget which overrides the create state method and returns whatever password strength field state. Returns password strength field state is a class that extends state of password strength field. All right. I have a variable is strong, defaults to false, and that's basically my state. Now in the build method of password strength field state, I return a scaffold with an app bar and a container. Container basically means, okay, I have a couple of elements which I'd like to return. I'd like to have a padding, and I'm using 16 pixels on all sides. This container consists of a column with a couple of children. Well, actually 2 children. The first one is a text field. Now, if you look in the Flutter documentation and look for password fields, you won't find anything, but you can use a text field and then use obscure text equals true. Well, probably not the most intuitive choice, but on the other hand, a password field may not offer any encryption or such. It's just obscuring the text while you enter it. So maybe actually that's close to the truth. And then on change, so whenever the text field changes, we update the state of our widget. We set is strong to, well, either true if the length of the current password or text entered into the field is greater or equal than 8. Otherwise, we set it to false. And of course, if you have a more complex heuristics like whatever, has to have extra length, can't have increasing numbers or repeating letters, stuff like that, then you just would put this in here as well. So that's the first element, the text field. And the second element is the text label that is shown underneath the field. And the text label is chosen password is either strong or not strong. So this is using the is strong state property of that class, and whenever the property is updated, so is the text field here. And that's it. That's basically the app, and that's how things are working. So we've seen stateless widgets, we've seen stateful widgets, we've seen event handling. So we have on change in the app here, we saw on click in the sample app before, and we saw how to create a state. And this leads you very, very far in working with Flutter and showed you the most important aspects. However, let me still show you a few more things. One of them is calling APIs. So doing an HTTP or HTTPS call to, let's say, a REST service or REST API. There's several approaches how to do that, but basically what you want to do is you want to do an HTTP call. There is an HTTP package which you can use then, and let me show you that real quick. There's a file called pubspec.yaml. Pubspec.yaml is a YAML file which, among other things, shows you which dependencies exist in that project. So for instance, one dependency here is Flutter, and Flutter needs its SDK. And we have Cupertino icons if you'd like to use Cupertino UI elements. However, we can also try to load other packages like the HTTP package, have to provide a version number. Then I just hit save. Does a hot reload, but I don't do anything yet. But then here, very, very small, almost impossible to see, pubget, which calls the Flutter CLI with pubget. And this now loads everything from that YAML file. So we can now use the HTTP package and work with the package. All right, let's revert this because we don't need it right now, but I like to show you how that code would work. I have a sample app that is kind of pulling sessions from NDC and displaying it in context of an app. And basically, since this is an asynchronous call, we get a future that's kind of like a promise, as you would call it in JavaScript terms. You get the HTTP client from the HTTP module and then have helper methods like get or post, and then you just do a wait for a response, and then you parse the response. The parsing, however, can be tricky because when you get JSON back, okay, you'd like to do a JSON decode. But what you get back from JSON decode is a dynamic type. And if you expect, say, a list of sessions, then a session could implement a from JSON method, which then helps you to convert this back. Why is that the case? There's no reflection support. So there is no easy way to do JSON auto mapping. So either if you have simple model classes, then you can just provide the from JSON method. On the other hand, there are packages that generate code for you. So you feed them a class and then they generate the code for you. But there's no automated support there yet for any automated mapping at runtime because of the missing reflection support. Actually, let me show you the app I've prepared here, so I can show you this manual model. So this is an app, and it's this app has a class called conference session. A conference session consists of, let's say, an ID, a title, a presenter, and well, a date or time or whatever. I just was lazy here and was just using a string. And this is a shorthand form of a constructor, and the constructor just knows if it gets these 4 parameters, then it sets those 4 properties by its name. And now I created a from JSON helper method, and basically I say, well, the ID property is in the JSON dynamic element, which I eventually receive. Well, the value for key ID, and the title is the value for a key title, etc., etc. Yeah, that looks so cumbersome to write and so boring that eventually you may want someone to generate this for you. But for simple classes, this might be an interesting approach, nevertheless. So we can call the API then, and what we can also do is after calling that API, we can process the data. Now let's see. It's loaded on the emulator now. So this is the app. It's calling a service on my local machine here, which gives me a couple of workshops and a couple of sessions. So how about Piotr's session, who was in this room before me? And oh, I'd also like to see my session and let's say one of those workshops. Yeah, if I click here on that burger menu, I get a list of the sessions I saved, which I wanted to attend, right? So a rather simple app, but well, it shows you a list view. You could also scroll if there was more than one. You can heart and unheart things, and you get this nice animation when switching between those 2 elements. And what I also have is a map of the Oslo Spectrum, where this conference are supposed to take place this week. And you also see here the logo of the Oslo Spectrum, which I borrowed. And let's have a quick look at some of the things how I made this possible. Maybe let's start with the map. I'll go into the YAML file here, and you see that I was loading the Flutter_map package. And this basically gives me the option to include any kind of map, Google Maps, Bing Maps. Are they called Bing Maps, Windows Live Maps? I have no idea. And OpenStreetMap. And OpenStreetMap is the one where you don't have to register. So guess which one I chose. Basically, what that then means is I just import the Flutter_map package and then just use the API. And there's a very healthy ecosystem of a lot of packages for all kinds of uses. So it's very rare that you have to reinvent the wheel. And basically what I'm doing here is I just create a new map. I center the map with the coordinates of Oslo Spectrum. And then I put in a marker. And as the marker, I am using the logo of the Oslo Spectrum, which I copied that from their website actually. But how does the generally work? I have build map, which returns a Flutter map. So once again, we have a widget here, and yeah, basically in that widget, we have a couple of layers, and Flutter then knows how to render this. But once again, we see the container widget, and the container widget has a child property, and the child property then could have a text, but here I chose an image. Right? So that works actually pretty nice. And the basic setup of the app, I can show it as well, is again the same thing we have seen before. We have a stateless widget, material app. Home is sessions, and session is defined further below. It's pulling up the data, and then shows you everything. Now let me quickly check. Yeah, here the tab animation. The tab animation is built in because that's part of the design approach and the mobile OS. So there's something called a default tab controller. There's also a Cupertino tab controller, which are then usually at the bottom. But this also expects just the UI element, a widget. Here it's again a scaffold with an app bar. And at the bottom, well, in Android design language, it's at the top. I have a tab bar. And the tab bar consists of several tabs, workshops, sessions, and map with icons. And I can assign actions. And well, I come to the actions later. But basically, these are the tab bar. And the body of the scaffold is the tab bar view with 3 children. And I have 3 tabs. And the only thing that is a bit weird here is the number has to be the same and the order has to be the same. So if I click on the first tab, I just go to the first child. There's no other implicit connection between those two. Yeah, and when I click on any of those icons, the heart icons on the right, I once again have an event handler, and the event handler is then storing this information. Right? So that's basically how these things would work. And there are many more options which you can do. And one interesting aspect which I'd like to show you is you could try to access system features. There's something called platform channels, and you can send data via the platform channel to a specific platform and receive data back from it. Because if you would like to access any system feature, let's just say the battery level of your phone, then you have to have a OS-specific implementation. You have to have one for iOS. You have to have one for Android because the APIs are different there. I mean, there are other APIs which are now kind of uniformly available, but they are just different. So you have a system agnostic implementation, and then you can call into that implementation via platform channels. You can read out information, you can change information, etc. However, not necessary to reinvent the wheel because there are many packages that could help you here. So if you go to pub.dev, pub.dev is the repository of packages for Dart and Flutter. So let's just search for battery here. And yeah, there is a battery plugin for Flutter. It's a Flutter favorite because so many people are using it. And this battery package, once installed, well, gives you something called battery, and then you can access battery level. As always, with mobile devices, the emulator only gets you so far when it comes to testing. However, talking about battery, just to show you that, in the extended options, you can go to the battery section and then, for instance, change the battery status. So let's just say this is only half full or half empty. And then this is not really reflected here on top. But still, if you try to query the battery level now, you'll get 50 as the value, not in contrast to 100. So some of those things can be tested, also geolocation and other stuff that can be set here. And the way you would use this is exactly the same as I've shown you before. So you go into the pub/spec YAML, use the package here, do pub get, And then in your main file, or if you have several files in the file that needs it, you can then just do something like import package and then battery dart. And then this would be available in your project, right? So really, really convenient. And once everything is done, you may want to deploy your app, right? And deploying is where it starts being completely system agnostic, because deployment depends, of course, on the deployment system. One thing is the launcher icons, or generally the icons the app is using. It doesn't come as a big surprise that there is a package as well, Flutter_launcher_icons, where you basically provide an icon and then you get it in the different formats required for the different operating systems, because they have, you know, different resolutions, and some of them need more, some of them need less, high res, low res, etc., etc. So you can do that. You can also do this, of course, specifically on your target system. So you can go to Xcode and then set the resources there, or here. Since we have Android Studio, let me show you real quick how this would look like. So you have this Android folder here, and don't worry, there's an iOS folder too. But here's an Android folder, and then you do new and then image asset. And what you then get is a wizard where you kind of provide an image, and then you get this in these different formats. And when you click through that through the wizard, then the files are put on in the project with the right names at the right places. And actually, I was using the sample app and I was putting it on my real phone, and then indeed I got this logo here as the logo as well. Also, since we're here on Android, there are other settings which might be of interest. So you can set several properties of the application. For Android, you always have the Android manifest.xml file, and in that file, you could set the name of the app. You cannot set that in Flutter directly, because at least as of now, because it's specific to the target system, whether there's a lame or a short name and a long name, etc. So this has to be set manually and specifically. And so here I set the name of the app to NDC 2020. So this is what shows up in the app launcher on Android there. Yeah, and once everything is done, you have to sign, you have to build. You have the command line for Android, and for Xcode and for iOS. Well, you'd have the two, but usually what you're doing is you just use Xcode. You go through the process of getting your signing certificate and get everything set up, and then you're ready to go, right? Deployment is an underestimated task, but on the other hand, once you're ready to deploy, the major burden of the work has already been done. And I think with Flutter, you have not too steep learning curve. You once have to wrap your head around the stateless widgets and the stateful widgets, but then you basically, well, assemble, combine your UI, set up the event handling. You have a myriad of packages available, which give you additional features, so you don't have to reinvent the wheel. And in the end, you have one code base and hopefully apps for at least 2 operating systems, if not more. And with that, I say thank you very much for tuning in. Apologies again for the emulator not working for the sample app, but for the more complex apps, it was working very, very well. A bit confusing, but well, I hope I could show you a good chunk of what Flutter is capable of doing and how it's working. And I'm looking forward to any of your questions, either now here live or in Slack, where I intend to hang out for the remainder of the conference. And hope to see you at the next NDC, maybe, hopefully, again, in person. Thank you very much, all. All right. I think we still have 1 minute to go before the next presenter would like to enter the room. So if anyone wants to ask a question now, do so now. Otherwise, please do send me an email, and I intend to reply as quickly as possible. I'll also send a link to the slides and potentially the sample app in the Slack channel. So this is Conference Room 2. So just go to Slack and then the Conference Room 2 channel. All right. I see no one raising their hand to have a chat. So I say thank you very much and have a great remainder of the conference. Thank you so much.